signal processing. Let us see some basic properties and its proof today in this video session. As you know, in DSP subject, a very basic formula is your DFT, which is discrete Fourier transform. We say it converts time domain x of n, it converts to frequency domain x of k. And some statements or some wordings we use which you should be very careful. If I make a statement like this and if I write DFT here, you should know DFT of x of n is x of k. I am repeating, this is time domain, it is frequency domain. DFT of x of n is x of k. I can also write like this. DFT of x of n, repeating, DFT of x of n is x of k. Both are same. DFT of x of n, DFT of x of n is x of k, which is summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi kn by capital N. I can say DFT of x of n for x of n. If I say DFT of ax of n, then what should be the answer? Summation n is equal to 0 to n minus 1 ax of n e power minus j 2 pi kn by n. This basic logic you should know. Even it is applicable for IDFT also. DFT of this term, same term is here. DFT of this term, same term is here. So just keep it in your mind. We do have various properties in DFT. One basic property is linearity. Let us say, if there is a time domain x of n, what is its DFT? Just now we told x of k. If it is x1 of n, then obviously it is x1 of k. What is its amplitude? 1. What is its amplitude? 1. Now, a slight change in my statement. If it is ax1 of n, whose amplitude is a, then it is ax1 of k. In time domain, if you multiply by a, frequency domain also you multiply by a. bx2 of n, what is its DFT? It's obvious. bx2 of k. Now, what is this linearity property says, which is a combination of, it's a superposition theorem. Like we can do additivity, and you can even multiply by amplitude a and b. The linearity property says ax1 of n plus bx2 of n, combination of these two. Definitely, what is its DFT? The linearity property says its DFT ax1 of k, its DFT bx2 of k, and if it is addition, even here also addition. So this is the property. Now, we would like to just prove this particular property. Just let us do some simple work. What is DFT of x of n? As per the formula, it is summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi kn by n, which is x of k. What is DFT of AX1 of n? Here it should become AX1 of n. What is DFT of AX1 of n plus BX2 of n? Whatever the term, same term. Whatever the term, same I am going to write. Summation n is equal to 0 to n minus 1 AX1 of n plus Bx2 of n e power minus j 2 pi kn by n. So DFT of x of n is here, DFT of this term is here. Basic mathematics. Let us split this. If you just split, we can make it as 2 summation n is equal to 0 to n minus 1 AX1 of n e power minus j 2 pi kn by n plus another summation is this term, summation n is equal to 0 to n minus 1 bx2 of n e power minus j 2 pi kn by n. Just splitting into 2 terms. This is one separate, this is one separate, in between plus. Who is A? Just an amplitude, we can take outside. Who is B? Just an amplitude, we can take outside. So if that is the case, A outside, summation n is equal to 0 to n minus 1 x1 of n e power minus j 2 pi kn by n plus amplitude B outside, summation n is equal to 0 to n minus 1 x2 of n e power minus j 2 pi kn by n. Who is A? Amplitude. Let us not bother. A is separate. This whole term, please have a look on this. Please have a look on this. It is the DFT formula. Actually, who is E? X of k. Then who is this person? X1 of k, because 1 here. It's simple. Plus the amplitude B. Who is this whole term? It is resembling DFT formula, but it is x2 of k. Hence proved. That's all. AX1 of n plus BX2 of n, its DFT is this term. Hence proved. Let us see the next property, periodicity. What is periodicity property? Says if there is a time domain x of n, it repeats for the duration n. It is same as x of n, which means in time domain, adding capital N, n is nothing but the length, or even you can say time period, adding n results the same. Not only in time domain, even in frequency domain also, plus n will resemble the same. So there are 2 properties in this periodicity AB, which means time domain also obeys periodicity, adding n results the same. Frequency domain also obeys the periodicity, adding n results the same. Now I would like to just prove this. Can you say what is your DFT formula? X of k equal to n is equal to 0 to n minus 1 x of n e power minus j 2 pi kn by n. What is this formula? DFT. Time domain, frequency domain. It's a function of k, so here k. It's a function of k, here k. Now it is a function of k plus n, then here also k plus n. Summation n is equal to 0 to n minus 1 x of n minus j 2 pi, come on, k plus n by n. Just resemblance. K, here also k plus n, k plus n. Just let us break this. Summation n is equal to 0 to n minus 1 x of n. If you break, e power minus j 2 pi kn by n, another term. e power minus j 2 pi n by n. Kn is available here, nn is available here. I hope you can see n and n cancel. Recall, what is its amplitude? 1. Value is 1. What is its value? 1. So just note see this. Is it not resembling your DFT formula? Equal to x of k. Hence prove. X of k is equal to x of k plus a. I just prove. The same work, let us prove this A. Time domain also obeys periodicity. I took DFT. Now I am going to take, I hope you can guess, IDFT. X of n equal to 1 by n, summation k equal to 0 to n minus 1 x of k, e power j 2 pi kn by n, which is your IDFT formula. Recall, there is n, here there is a n. If it is n plus capital n plus capital N, obviously there also same rule, n plus capital N. 1 by n, k equal to 0 to n minus 1 x of k, e power j 2 pi k n plus capital N by capital N. Just n plus n. Break it. 1 by n, k equal to 0 to n minus 1 x of k, e power j 2 pi kn by n. Another term, e power j 2 pi kn by n. N and n cancel. Obviously, what is its value? 1. No issues. This is ditto IDFT. So, who is E? X of? Who is E? X of n. It's IDFT formula. Hence, proof x of n is equal to x of n plus k. Thank you.